Everyone, thanks for coming. My name is Lyon. I'm from sunny Singapore. I work at a company called Vantage Point Security, which is based in Singapore. And I spend most of my time doing web application pen testing, mobile network, anything that a pen tester do. And during the night or during my free time, I do research on anything I like. And just the past year, I've been researching on IoT devices, which is why they're researching this is because Singapore wants to become a smart city. If you go to the Singapore airport, there's even smart dustbins and yeah. Previously, I spoke at a few other conferences in Hack in the Box, XCon, DEF CON IoT Village, gave a ARM exploitation workshop at DEF CON IoT Village. And yeah, today I'll be talking about advanced SOHO router exploitation from the simple low-hanging fruits, web vulnerabilities to writing exploits on Stack Overflows that I've discovered on the routers. So today I'll share a story. 1 year ago, I attended Colin training, and he's like the x86 guy, right? So I've got inspired by him, and I thought of contributing back and giving him more content on writing exploits on ARM and MIPS. And yeah, hopefully pop more shells as we go. So who am I? I'm a rather regular guy, basic understanding of assembly, did some training, and yeah, and as I said, spend most of my time in the night. It's almost like I have a double life. In the night, I research on all these routers, and yeah. So the current state of embedded hacking is rather immature. There's contents online, but there isn't really a methodology. Like OWASP top 10. There are contents online, but it's really scattered, and yeah, it's not easy that if you want to start hacking, and you have something that you can refer to. So the current security of IoT devices is like back to the 1990s, right? You can find all kinds of ridiculous bugs, Stack Overflows everywhere. There's no privilege separation. They don't secure the host. There's backdoors, and yeah, it's almost like these vendors do not care about security. So I want to share a bit of story. I was testing this particular router, and I found like maybe 7 or 10 vulnerabilities. And I tested another router, different brand, different vendor, and I find the exact same vulnerability. It's the exact same URL, exact same path, everything exactly the same. So what does this mean? It's almost like these vendors do not care about security. They just bought this off-the-shelf software, put it into this box, and just ship it out, right? Yeah. So the current state of embedded security is like these vendors just want to monetize money and just buy all this off-the-shelf software, put it into the box, and yeah, sell it to you. So when we want to attack an IoT device, we want to look at the attack surface. We want to understand why we're pen testing or finding bugs. We want to find every single entry point where we can attack. So is it ARM or MIPS device? Is it most commonly runs on Linux? And can we attack through the Wi-Fi, UPnP? And there's really lots of services where we can attack. So when one of the other avenue where we can look at is the hardware. In the hardware, we can do it through the we can try to get the image out and start looking for reverse engineering and look for bugs. So what I did was I took the chip, the IC chip, I desoldered it, took the chip off, put it into an adapter, plug it into your laptop, and you will have the firmware. So once you get the firmware, you can start digging through this firmware and understand what's running on it, what software, and basically find every single entry point. Other ways where you can do this is find firmwares online, of course. That's the easier way where you could do. And yeah, most commonly I use Binwalk or any other freely available tools where you can unpack this firmware and understand what this software is running. So at Vantage Point, I work with a few IoT vendors, and most commonly I like to attack is the HTTP and Telnet service because that's where most of the bugs are, and you can easily test them. And yeah, so most commonly the bugs where we find is like most commonly you see on the internet is every other month there's always someone publishing a 0-day on any IoT device where you can find these backdoors where security is not implemented at all. There's directory traversal, stack overflow through the UPnP, command injection, and it's a whole new playground in an IoT device, right? There's all kind of bugs where you can find. And in IoT, we want remote unauthenticated bugs. We don't just want 1 0-day, but we want 10,000 0-days, right? Because as a hacker, if I want a botnet, if I can control 10,000 devices or a million devices, I can do so much things. So the reason why I like to look at Telnet and HTTPD services is because these two services are most commonly open to the WAN by default when the vendor ships the router to anybody who uses it. So as you can see in the graph on the left, this is taken by Shodan. So the 0-days that I discovered for this particular router, exactly right now there's thousands of them open to the internet right now, where we can just hack in and gain control over the router. So why are there so many 0-days? As I told you before, the story where these vendors really do not care about security. Also because typically you see these developers, most commonly I do not know a lot of good C or C++ developers right now. Most people know ASP.NET, Java, PHP, or now most Python. So none of these developers really know about C or C++. So these developers take this off-the-shelf software like micro HTTPD, and they customize it, and because they customize it, that's where these vulnerabilities are. So they do not know how to code in secure C or C++ coding, and they just use string copy, and you can easily find stack overflows everywhere. So typically, I find bugs like this. You can just easily just do a stack overflow in the header or in the telnet, and very easily you can find stack overflows. One other avenue where a lot of people don't look at is the UPnP. In the UPnP service, you can just fast every single parameter or header in the UPnP request, and you can easily find stack overflows. So today I'll be talking about a few 0-days that I discovered on the Zone router. So who exactly is Zone? They're based in the US, and they provide these routers for ISPs or small enterprise networks. And why did I look at Zone? So one, nobody actually looked at it before. And two, my ISP forces me to use this router. And they actually make me pay for this router to rent this router from them, this shitty, crappy router. So they gave me this router, and I wanted to, I'm a security guy, right? I don't want to be hacked. So I want to configure it, right? But they only gave me user credentials. So I called the technical support, hey, can I get admin credentials? I want to do some configuration. And they said no. So challenge, right? Game on, right? Let's go. So I started poking around the router. So just to see how many ISPs are using right now. So if you go to Shoulder and you just search for Zone, you can actually see there's quite a few ISPs that are using this router. Yep. So I started looking at it. Of course, easily in all these IoT devices, you can find cross-site scripting, and you can just put a stock cross-site scripting, and you can start attacking the tech support. But I live in Singapore, and law is very strict, so I can't attack my own tech support, right? I don't want to go to jail. So I started digging through the router, and what I realized was there's no privilege separation in between the users. So basically, any user can call any functions. What they did is they did this privilege separation via the JavaScript. So what we can do is just call any administrative functions, and yeah. But as the user, when they gave me the router, I do not have the admin functions, right? I don't have the exact URL, and it will take some time to find all these administrative functions. So If you see on the JavaScript on the right, it says if user equals to admin, show the admin menu. So basically, you can just put it through burp and just replace the admin. So every admin word will replace it with user. So if user equals to user, display the menu. So then we can see the menu and we can start configuring the router. And yeah, most commonly you can find in all these routers that actually they do not put proper session cookies in configuring these routers, and you can easily find all these 0 days. So yeah, so now I have the admin functions. I can configure the router right now, but of course I want to start looking for more, right? I want the password, I want to change. I don't want the tech support to be in my router. So I started looking, and what I realized was that they stored the passwords of the administrative function, of the administrators and the support account in the backup file, base64 encoded. So I just get the file, decode the base64 password, and it's just right there. You can just have the admin password, the support password, and the user password. So I notified the vendor, and they patched it. So they patched it, and what I was thinking, when I downloaded the backup file, I can get the password, right? So now they remove it from the backup file. Why not try uploading it back and patch the password myself? So I don't need to know the password. I just do a simple upload settings using the functionality, set the admin password, and then I reset the password. So this is great. So now I got the admin password. Yeah, so this it's not affected on this router. You can try it. A lot of other routers. I actually tried on a few routers in Singapore, and it's the exact same bug. You can just grab the backup file and you can have the password. So yeah, now I have the admin password, but my main goal is I want to get root shell on the router. So when I get root shell, I can start finding for more vulnerabilities. I can start fuzzing the router, put my GDB server on, and start fuzzing it. So I turn that in, and of course they gave me a restricted shell. And in a restricted shell, you can easily just pipe it. And when you pipe it, you can you just pipe behind any command, and you can start running your commands. So now, when I'm in the router, right? So I finally managed to get shell. So I start grabbing all these files. The first thing I like to do is start grabbing all these HTTP service binary, whatever binary they are running, and put it through IDLEPRO and start looking through it and understanding what it's doing. So I put it in IDLEPRO. I took the HTTP service, put it in IDLEPRO, and I want to look for shell, right? I want to look for more shell. So why not just search for shell? And what I found was there's a lot of commands, function names, with the word shell inside. Run command in shell. So I started digging through all these functions, and what I found was that actually you can easily find in their trouble, it's most common in other routers also, where you can just pipe it in the ping functionality or the trace route functionality, and you can start running your shell commands. But the problem is when you have a router and it's black box, you wouldn't know whether you're running the commands. So, but because I was a root user on the router, I can just run it and verify that I managed to write some file into the temporary directory and things like that. So what I did was I download my shell, put it into temporary directory. Usually I like to write it to temporary directory because that's the place where it's most commonly writable. Most of the other places on the router are only read-only and you can't write to it. So I like to, if you're doing a black box and you might think maybe in the ping functionality you can run shell commands. So you try writing it to the temporary directory, change the permission of a shell to write executable, run it, and hope that you pop your shell. So then I started, so now I have, I have access to the router. So I put, what I like to do is put GDB server on the router. I find that works very well for me. Other than putting in QEMU and try to replicate the firmware on QEMU, that's a lot of work, and sometimes you just can't make it work. So what I like to do is put GDB server on it, run GDB server, attach GDB server to the process, the HTTP process, and start fuzzing it. So for this router, you can easily just do, as you can see, 7,000 A's in the header, and at the back, you just put any extensions that's available, and hope that you will get your Stack Overflow. So I did that, and And yeah, so this is what you'll see on GDB server if you manage to trigger something. And what I managed to do is I managed to trigger, I managed to overflow the stack and gain control over the program counter. So what exactly is program counter? Program counter is like your, if you know x86, it's like your instruction pointer, which what this program counter is it controls the flow of the program. So it points to a location of the program, and you can actually point it to the location of a shellcode and gain full access to the router. So for this case, I was lucky where I also have other registers where I can use. All the registers here I can use, and this is very helpful because you can place your rob gadgets addresses there and you can use it to write your exploit. Before I write the exploit, I like to find out what restrictions I have. So if the stack is not executable and you waste so much time writing the exploit, then you waste time. So for this case, I was also lucky where the stack is executable. So if I place my shellcode there, it will run. So when you come to writing exploits on MIPS architecture, there's a common problem called cache incoherency. In cache incoherency, what does it mean? So if there are instructions that were already in the instruction cache, and when you send your shellcode over, the instruction cache will always take priority over any other instructions that you send over. So what you need to do is you need to flush the cache in order to get your exploit to work. So as you can see here, on the left is the, on the right is the instruction cache, and when you send over, your instructions also will be in the data cache, and because of this, there will be a cache incurrency, and cache incurrency always takes priority. So to overcome this, we need to flush the cache. In order to flush the cache, we need to call a sleep function or any blocking function that would help flush the cache. And to do this, I would use the rob gadget. So what are rob gadgets? Rob gadgets are like your, so for example, in a binary, in HTTP binary, if you put it through either pro, there's a stack of instructions. So by using any of these instructions in the binary, these are your rob gadgets. So what I did was I used the libc library, which is attached with the HTTP binary, and go through the libc binary and look for the sleep function. So the first rob gadget I would like to do is to set 1 to A0. So you don't want the sleep function to sleep forever. You want to sleep like for 1 millisecond. And the second one is to call the libc function. And so now, after calling the libc function, we managed to flush the cache. Now we need another 2 more rob gadgets to jump back to the stack and execute your shellcode. So most commonly, I find quick Hefner's either pro script very easy to use. You can just put the binary through either pro, run his script, and you can actually see the stack, the list of rob gadgets where you can use to help write this exploit. So now I have my rob gadgets. I'm excited to pop my shell, right? So I wanted to quickly write this exploit. So I quickly went to Metasploit, used the encoder, and generate the encoder with the shellcode, to overcome the back characters. And then when I ran it, I was like, no shell. I was like, what's happening? I got my rob gadgets, I got my shellcode, everything. I traced through GDB, and the weird thing is when I trace through the GDB, I pop my shell. But when I turn GDB off, I don't get my shell. So I was looking through the encoder, and I didn't really understand what the Metasploit encoder was doing. It was calling some weird system calls, and maybe there was something with GDB, I'm not really sure. So what I did was I realized actually in the shellcode, there's actually very little back characters. So there's only 2 back characters where it's causing your shellcode not to run. So you can actually, what you do is you can simply write a simple Metasploit encoder. So you can just encode the 2 back characters, and on the fly you decode and just these 2 back characters, and you're good. So this is just a simplified version where I just XOR both the back characters with 9999. Yeah, so now I'm again excited, right? So I got my own encoder, I got my rob gadgets, I got my shellcode, and then I ran, and then it died instantly. I was like, oh my god, like what's happening? So I started looking through the router, and I was figuring out why I get my shellcode, my shell popping back, but why is it not working? So what I realized is actually most routers, they have this service that monitors all these critical services, HTTP service, telnet service, and when it finds that it's not working, it kills the service and respawns it. So this is a problem, right? I popped my shell and the HTTP service wasn't working, and of course this service would kill it and respawn it. So what I found, the solution is to actually fork the shellcode. So what does fork mean? Fork means you're actually spawning a new process for this shellcode, and even if the parent process dies, which is the HTTP service, your shellcode will still work. So I forked the shellcode and managed to pop the shell. So just to recap, for MIPS exploit writing, you can actually, there are 4 things: clear the cache. In order to clear the cache concurrency problem, you need to sleep, or any other blocking function. ASLR, to bypass ASLR, you can actually just use any rob gadget, which we will be using with the cache concurrency. For back characters, you can write your own encoder. And for the auto respawn process monitoring service, you can actually just fork the shellcode. So just to show you how the GDB server works and how I trigger the GDB, how I trigger the Stack Overflow. Okay. So now I'm in the router. I telnet into the router. I'll run the GDB server. And set GDB server to run on port 1234. Okay, so now it's running. And on my client machine, I run my own GDB. And so now I'm attached to the GDB service. And on the router, now I want to get the HTTP service process ID. Over here, I'm just setting a HTTP request so that I can tell the router to spawn the process. So now I have the process ID over here. So now I'm attached to the HTTP service process, and now I want to trigger the exploit. So what I'm doing here is actually just sending 7,000 A's in the post request body to trigger the exploit. So if you see here, 414141, so we managed to trigger the exploit. If you look at the registers, we have control over the program counter, and we can start writing our exploits. But yeah, of course, you guys want to see a shell, right? Not just Stack Overflow. So now to look at the exploit, just briefly, you can see I'm sending to the host, which is the gateway, the router gateway, 192.168.1.1. And for S1, which is I'm setting the S1 register to the sleep function address to call the cache concurrence, to flush the cache. And S3 is the second rob gadget where we can use to to jump back to stack. Yep, and other things that we have explained that I'm using. The exploit's a bit messy. Yep. So basically what I'm doing here is setting the registers, putting my encoder in, and running my shellcode. So I set the shellcode to connect back to this IP address on port 12347. So I run the exploit, and then shell. So now I have shell and so I'm root. Yep. And if you want to see the password file. Yep, so that's how you write an exploit on MIPS, and yeah. So just to give a bit of tips on how to write on ARM instead, ARM architecture. So in ARM, there's also the cache concurrency problem. So why is that? Because when you're writing the exploit, there is the encoder, and in the encoder and decoder, it's called self-modifying code. So in self-modifying code, there is always because you're modifying code on the fly, and when you modify code, it will cause a cache concurrency. And as I said again, instructions stored in the instruction cache will always execute instead of the data cache. So yeah, so when you modify the shellcode in the data cache, you will have the cache concurrency problem. So one tip that I can give you is what I found out that works best for me is to just encode and decode only the data portion of the shellcode. So why is that? So in the shellcode, you can always easily write the shellcode such that there's no back characters. But in the data portion where there is your IP addresses, your port number, that's the location where there's always the back characters, where there's the null bytes and things like that. So what I realized is just to you write a shellcode where you avoid all these back characters, and only in the data portion you encode it and decode it. So just to give you an example of how it works, so you have your decoder, where on the fly you decode the instructions in the data portion of the shellcode, and now it's decoded, and when your shellcode runs, it actually reads the data from the data cache, not the instruction cache. So that's actually how I bypass some cache concurrency problem when I write shellcode for ARM. So yeah, so what do we do? There's still a lot to protect in IoT. It's almost like protecting a network, right? There's so much services, telnet, HTTP service, web, wireless, and you need to harden the host. And when you compile the binary, you need to compile so that you have some options to prevent stack overflows, enable ASLR, and there's so many things you need to do. For hacking routers, these are the two references that I like to go to, Craig Hefner, and for writing ARM exploits, I like to go look at Jonathan Sawan. He has a very good tutorials on how to write exploits on ARM. And yeah, I'd like to thank these guys for helping with my research. And if you have any questions, you can reach me at my Twitter and my email address. Yep. Thank you.